Hello and welcome back to a new video here on the Ludwig Fusel channel to another C++ tutorial. Now in the last video we have implemented our first class and I hope it wasn't that scary, but I tried to get you to that step by step by starting with a struct, and I think at least when I've cut it that I had a good idea that this might be understandable. So yeah, here are we back in the video, and what we want to do today now is I want to talk you through how we can now start and talk about constructors and destructors. Now constructors and destructors in general are special functions that are called when an object is created or destroyed, or better to say when an object is allocated, for example with new, or destroyed with delete, or destroyed in any other way. So they are really handy functions. They can be used to automatically clean up resources, to automatically allocate resources, to automatically acquire resources, to automatically free resources, to automatically save files, to automatically store logs, to automatically do whatever you want to do, locking files, locking directories, making sure that stuff is only accessed by one application, and all stuff like that. So constructors and destructors are a really handy tool for automating your call of functions. Now, are constructors and destructors something that we have previously used? Yes, they were already used, but we haven't seen it. Now, every class that you're going to write in C++ is going to have a constructor and also a destructor. So in general, what they are doing is every member that you have in your class, so every variable inside the class, is automatically constructed and destructed. So for example, you can see that our values was by default set to null pointer, our x was set to 0, our count was set to 0, and our function was set to null pointer. And this was actually done by the constructor of the class, so a special function that automatically set all these values. Now if I would try this out again and try to show this to you, let's quickly enter two values here and make a breakpoint here before we kind of like create that object here. You can see that before we create this, the values are like 0, minus, several things. Like all these values are an invalid value. If I would add now a breakpoint down here, and I would hit continue, you can see that they are all getting values now that make sense. And this actually works by calling the constructor. So let me actually show this to you an even better way. Let's go to the disassembly. We already did this previously, and you can see that we have my multiple functions that I called here. Actually, you can see that two things are done here. Something is called like an auto class init2 and the function precacher, whatever that is. So two functions are actually called before we are getting to our PC setup. Let's actually take a look at these, what they are gonna do. I'm not gonna, I don't know really what's going on, but let's see what it's doing. So first of all, let's take a look at this. You can actually see that this pointer here is set to some invalid data. If I would now hop through that code, you're gonna hopefully see that it maybe does something here. Yeah, there you can see it. Now something has been done. You can see that now the values have been changed. They are still changed to nothing that really makes sense, but you can see that they have changed like the address of this pointer. Basically what happened here is the data has been pushed on the stack. So basically data is inside of the stack. Maybe we are already initializing some data. Are we already initializing data? Yeah, we are doing. You can see that we are kind of like filling all the data with 0. And if I go through this a few times, you can see how every member of the struct step by step getting zeroed out. And at some point we're going to go back, and now we are going back to the function precacher, which is also doing some stuff again. We don't really care what this one is doing. It's also just doing some magic stuff around that thing. And general, the idea is when all this like default stuff, this default constructing stuff is done, our class has been properly initialized with values. So the constructor isn't really like something new to us. The destructor on the other way is something. And the destructor is something we haven't really talked about, and I think it shouldn't also be used. It might be already used, but it might also not be. Let's take a look at this actually. Is the destructor actually called at some point? No, actually the destructor is currently not used because there's nothing to do. In general, what the destructor is doing, it's doing the same thing that the constructor is doing, but the other way around. It's trying to clean up all the data or all the resources that you have used. How is it doing this in general? In general, it is not doing this at all, because so these are all primitive types of the C++ language, like integers, pointers, and stuff like that. These are all like numerical values that don't need any special cleanup. This is why no destructor is used. However, what it tries to do by default is always tries to do its best. So its best is done by basically trying to destroy every object that is possible. So if you're using a more complicated object, the destructor of this other object, so if you have like an object inside of an object, kind of like two-way hierarchy, you have an object A, and object A has an object B, for example, and object A gets destroyed, it's automatically gonna destroy the object B as well, because object B is used inside of object A. So if object A gets destroyed, object B gets destroyed as well. We're going to talk about this way more in details in the future. However, I just want to kind of like explain the basics behind the constructing and destructing. In general, constructor used to initialize everything, destructor used to clean up everything. Now, have we use this properly, constructing and destructing? Let's take a look at our object. Well, our object PC is doing some stuff. It's setting up something, it's computing something, it's printing something, and we are releasing something. Does it really follow the idea that the destructor cleans up? No, it actually does not. Because this object here, the function precacher PC, actually requires the manual call of the function release. If we don't do this, we're going to get a memory leak. Let's quickly try this out, right? Let's write some cout so that we can check this. So when we are allocating something, let's say std cout, allocated values with, let's maybe also say this, size of int32t times count, and then we say bytes, and we add an end line. So this is when we allocate values. Maybe we want to have some quotation marks around here so that it looks nice in the console. All right, so now it's telling us that it allocated values with that many bytes. And when we delete this here, I also want to echo out that we deleted it. So std cout deleted values. Alright, so deleted values. Okay, so let's make this here, maybe add an end line here, so that we are fine. Alright, so now we basically echo out that we allocated delete. If we run this normally, you can see how like our pointer is living. So we allocate something, 5 and 5, and you can see allocated values with 20 bytes, and down here deleted values. So everything is good. We allocated it, we deleted it, now we are good. Now, however, when we are commenting out that last line, the PC release, maybe we forgot it, or if you want to reuse it, for example, you just want to use compute, print, compute, print, compute, print, and at some point the application terminates, wherever it might terminate. Actually, it can terminate earlier on if something goes wrong. Then PC release would not be called. If something in print goes wrong, PC release will never be called. And if we try to simulate this by basically commenting out PC release and we try it out, we can see that we allocated values with 20 bytes, but we never got the message that we freed the values. So we never released, or how did I call it? Deleted values. So we never deleted now the values because we have not called PC release. Now, this is bad because now we have a memory leak, and the memory leak is bad because these, how many bytes were they? We have 5 and 5, we had 20 bytes. Like, these 20 bytes are now lost. We can no longer reclaim these 20 bytes because we have forgotten to delete it. The pointer is no longer existing because the object function precacher is already destroyed. We have no longer access to that after that line, and the memory is now completely wasted. Of course, it's not wasted in general. Of course, when the application terminates, Windows reclaims all the memory that the application is used. So in this case, it doesn't really make a sense. However, if you would have a loop, for example, if you would to do this 4 times, like, or let's do it a few more things. Let's like start at 0 and say I equals 0. I smaller, let's say 2000, and they're gonna say I++. And if we now wrap all this code inside that for function here without calling PC release, let's maybe comment out print, because printing takes time and I don't want to print time, so I already get enough outputs of allocating the values. And if I do this like that, you're going to see that we get a hell of a lot of allocating the memories. And the application already terminated. All right, so the application terminated, so this was way too low. Let's add a few zeros in here so that we can actually observe what's going on. And while it's like crunching these numbers, you can see here on the right on Visual Studio, the memory is climbing and climbing and climbing. We are using way more memory everywhere. We use memory, but we're never freeing it. You can see our application eats away memory without releasing it. And actually the idea is, as soon as PC is kind of like invalid, we want to make sure that actually the memory that we used was also deleted. And this was called a memory leak because we are like climbing on the memory, but we are not releasing it. And yeah, we're doing bad things. And this is a memory leak. Let's actually stop this and let's show you what happens if I add the release back in. If I would add the release back in on this idea, you can say 5 and 5. And you can now see that we're already getting this like allocate, delete, and you can see that our process memory is steady. It's not climbing up at all because we are properly releasing the memory before we are using new memory. So you can see release, delete, or allocate, delete, or new delete, however you want to call it. But you can see no memory leak, everything flattened out, everything is good. And yeah, that is how we want to have it. However, what might happen is that release is not called. Release might not be called because something else, like there was an if true. This if true is now, of course, or let's say if one, we haven't talked about proper booleans yet. If run, then we say continue. Continues on with the for loop. So now you can see release was called, but somewhere in between a hell of a lot of code, we had a continuous statement. And this continuous statement resulted into PC release not being called. And boom, we have our friendly memory leak back because PC print is not called properly. And this is bad. We have our memory leak back there. Now, you could argue with me and say, why does the default destructor not remove the memory? So if we have a pointer here, why wouldn't the default destructor of the class here of our function precacher, why wouldn't the default destructor not clean up after ourselves and delete the memory? Well, the result is because it can't. Why doesn't it can't to do this? Well, because it doesn't know what the values are. The values are just the pointer. However, it doesn't know how the pointer was allocated. Was the pointer allocated using new? Was the pointer allocated using new with the array operator? So should it use the delete with the array operator as well? Was the memory allocated with malloc? So should we use free? Was the memory allocated with some custom allocator written by the user? Because you can write your own custom memory allocators in C++. So it doesn't know what's going on. Maybe it wasn't even allocated at all. Maybe it's just a pointer on the stack, right? It could be a pointer to the stack. It could be the pointer to a to memory from the system that was allocated with a Microsoft function, which also needs to be freed with a Microsoft function. So really, what the C++ language doesn't know is how that pointer was allocated. It doesn't know that, so it doesn't know how to free it by default. And on the other hand, we might even don't want to free it. Maybe this is a pointer that was allocated somewhere in our code. We allocated this in our main. We are freeing this in our main, and 100 objects are going to get these pointers. So if one object gets destroyed, it might not want to delete it at all because it's not managing the memory. And this is like the whole glory of memory management in C++, because you can go to town with that. So you can write your own memory allocators, you can write your own memory resource management. So this class is owning the pointer, the other classes just have the pointer as a reference without owning it, so it shall not delete this. And this is like the reason why no class or no default constructor will ever clean up your pointers. And that's very important, because if you have a pointer and you never call like your release function, the memory is wasted, because again, we don't call delete, the pointer is no longer accessible, and we have a memory leak. And we want to solve that issue. Well, we currently solve this issue by calling release. Now we could say, all right, let's duplicate release and move it up here before we call continue. However, this as well is not a good idea, because you always need to remember to call release. Wouldn't it be really helpful to tell the C++ language that it should call our release function when the object gets destructed or destroyed? It would be. And this is where we are getting to custom constructors and destructors. Custom destructors allow us to add features to the construction of objects. So by default, it's just initializing these values. But if we might already want to initialize this pointer here, then we could write a custom constructor, which is automatically calling the allocate function for the values. Or what we could also do is we could write a custom destructor that's initializing x and count to a certain value. And on the other hand, we also can write a custom destructor that automatically calls release for us. So let's do this. Let's start with the destructor, because that's the problem that we always face. Now, how do we tell the C++ language that we want to write a destructor? Well, we're going to overload a certain, it's not called an operator, but it's quite similar to an operator. We're going to overload a special function that is the destructor. In Python, it might be called destruct, but in C++, it's completely different. On C++, the function that we now want to override does not contain any return value and does not get any special name. So destruct That's not something that we want to do. Destructors doesn't work. Destructor is a function name that you could use. And in C++ in general, every name, you can use it for free. The only name that's reserved inside of a class are the members. At least if you are... then the name of the members are reserved in a class, and the class name itself. The class name itself is reserved for the constructor and the destructor. So by writing a function like that, you have a constructor. Now this is a constructor. You can see it's looking a bit different, but this is actually a function constructor. It doesn't get a return value, it doesn't get a void. You can see if I give this a type, it doesn't work. This is because the constructor and the destructor are return valueless, because they are not returning anything. If you are creating a constructor, the constructor is called to create your object. It is not like returning you something to the user application. It's just constructing an object. The same with the destructor. You don't get anything back if you destroy an object. It's like a static destroy the object. Now, if this is a constructor, how can we do a destructor? Well, a destructor is actually a bit more complicated. The destructor needs a special sign. Now, what did they use? They used the tilde. The tilde is used for the destructor, and they just did it like that. There's no, like, again, there's no like logic to this, why they use the symbol. They used the symbol because it was available and it is short and easy to write. But you could also like write an add. Like they have come up and could say we use an add, but an add doesn't work. Or also a plus, it also doesn't make a sense to have a plus. Minus would have make a sense. So maybe a destructor would have a minus, and the constructor that would have a plus would be something that might be a thing that might be logical. But they haven't done this. They have used this tilde symbol. Now we don't want to write a constructor yet, we just want to write a destructor. So this is a destructor. How are we going to implement this? Well, you're just going to give it a function body, and you can see now we have written our own custom destructor. What we can do in our destructor, we can call our release function. So I'm going to call my release function here, and this is going to make sure that when the object is destroyed, my release function is called and the memory is cleaned up automatically. And this is everything that we need to do. So if we now keep our memory leaked like that, and would run this, you're going to say, if I enter the values, that we allocated, deleted, and you can see that the memory is not climbing because we are automatically calling the destructor, because this object here goes out of scope. As I told you, the same with variables, they have a scope. In this case, inside the for loop here, we have the object created here with PC, and as soon as this object goes out of scope, it's automatically destroyed. So if we call continue, we are kind of like jumping back up to the body of the, or not the body, to the head of that for loop, and this means that the function precacher PC goes out of scope. It's no longer available. This iteration of the for loop is done by calling continue. It goes out of scope. Okay, so if it goes out of scope, the language is going to call the destructor, and the destructor calls release, and the memory is cleaned up properly. Now, of course, we can condense this even way more down, so we can make this again to our example that we had here. This is going to perform the same way. This is also going to automatically call the destructor. You can see it deleted this. It works like a charm. It works easy, and yeah, it's nice and simple. Now, of course, this also works for new and delete, so let's move back to our initial form that we had here. So PC setup compute. If I would say make this a pointer, and I would equal this to new function precacher, and I would use the pointer operator here. Of course, this works the same like with on C. Pointers are just replacing the dots with the arrows, and with objects it's the same. You can call the functions with the pointer operator as well. We now delete this down here with delete PC. If we do it like that, you're going to see as well 5 and 5, allocated values, deleted values. Maybe we want to put our print back, PC print. Let's add the print in here again so that we can see something. And it's going to still perform the same way. So 5 and 5, it's going to print out the values, allocated data, allocated values of 30 bytes, output everything, and it's also going to tell us that it delete values. Now, works the same. Now, one important thing, if you're using pointers, again, the C++ language will never clean the pointers automatically. If you have a pointer, you always need to have the delete. If I don't have the delete, of course, it will also never call the destructor of your object. This is the same issue that we had previously. Pointers in C++ always need to be deleted manually, so you're going to have to delete PC here. If you don't have it, it's not going to work. But in general, the idea of using a pointer for something like that is really stupid, because it's not required. And so we want to use it like the default way. Alright, so yeah, that's working like that as well. Now, one thing you could now think that we want to completely remove our release function and just do it in the destructor. This is something that I would never recommend. I would always recommend you that you always have the possibility to delete an object prior to its destruction, or at some certain points it would be good here, especially on that thing, because you might want to reuse that object to get some new data in it, to set up it new. It just makes sense that you have like release and setup as a different function. However, what I want to do now is I want to show you how you can write a constructor as well, because this video is not just about the destructors, it's also about constructors. Now, what would be something that you might want to have in a constructor? Well, the function precacher got set up with x count and the pointer to f. Wouldn't be that something that might also been supplied in the constructor? Yes, it would be. We want to actually supply this in the constructor, and we want to manually then call the setup function from our constructor so that we don't have to write two lines, right? I want to be able to just say, all right, give me a function precacher with x count and the function. Then it shall compute something and it shall print. This is something that I want to do. And actually, as you can see, it's done like that. I already spoiled the syntax on how to call constructors explicitly, but let's not spoil here. Let's get this manually done. So set up again. All right, so now let's write a custom constructor. Now, custom constructors can be written in several ways. Now, this is a custom constructor in the default way, right? I could like echo out something. I could say object created and write std_handle, and everything would be good. One important thing, if you are calling a constructor or destructor, the default ones are still gonna be called, right? Even if I haven't specified anything here, it's still gonna initialize all my values, and if we are destructing something, it's still gonna destroy all my objects. So in C++, just that you are kind of like writing your own custom constructor and destructor, it's not gonna remove the default behavior. And just some background information. And if I do this like that, you can see that I've entered my values here, and we are gonna get some output, object created, allocated values, deleted values. So you can see that our constructor has been called. Now, however, our constructor doesn't make any sense because, well, the default constructor, we want to keep this as is. However, what I want to be able to do is I want to be able to give the object the potential to be constructed already with the values that we need for setup. So what I'm going to do is I'm going to copy the signature here that we had for setup, and I'm going to paste this into a constructor. And you can see that this is going to work because we don't get any issues. Now what this is doing, it's defaultly initializing all my values, and then I'm ready to go. And what I want to do in this constructor, I want to call setup. And by calling setup in here, I'm going to set up my constructor or my class, my object, with the x count and the function. So by specifying this constructor above here, we are giving it a new form of how to create the object. So if I would now scroll down, you can actually see that we're going to get an issue here because PC can no longer be created. If I hover over that, you can actually see no default constructor exists for class function precacher. So the C++ language is no longer be able to create the object without any parameters. That might be good or bad. You might explicitly want to say, all right, yeah, this is how I want it. I want to be able to just create this object by giving it these parameters. However, since we have the setup function, we might also want to be able to kind of like create an empty object. We might want to be able to create an empty object and set it up later. So what I want to do is I also want to provide the default constructor. You can actually write multiple constructors. You can write how many constructors you want on your class. In this class, I have provided the default constructor here without any parameters, and I don't have given it an implementation. And if I would now scroll back down here, you can see that my code again works. And if I would run this, you can see it's still going to get the same output. We construct it like a default object, and then we set it up. However, what I don't personally like here is that we have this empty function body. We can do this better. Yeah, we can. We can actually write default behind it. So we can actually take that constructor and assign a value called default to it. Now this looks like a value assignment, but it's basically telling the language that it should allow the default implementation. As soon as we're having kind of like a custom implementation for a constructor, the language is going to assume, all right, if you have a custom implementation, the default one is not going to work. And by adding this line, we're basically telling the compiler, the language, hey, the default one should still work. And if we scroll down here, we have no issues. And if I run this, the output is still going to be the same. So we can still use the same features here. What you can also do is you can explicitly delete a constructor. So as you can see now I have explicitly said that default constructor is available. And what I can also do is I can also say delete. If I assign this to delete, it is like deleting that special kind of constructor. This is especially useful when we are getting to the big 3 and the big 5. The big 3 and the big 5 are special functions I don't want to talk about them yet, but they are by default supplied by the language, and if we don't want to have them available, we can explicitly delete them so that you can see that they are not available. In this case, I just deleted the default constructor, and if I scroll down here again, you can see again we have the issue. The default constructor cannot be referenced. It's a deleted function, definitely says what's going on, can't compile this, it's going to give us the same error, and it doesn't work, right? Personally, I don't want to delete it above here, but yeah, let's just put it back to default. Default. There we go. So that it is being able to use. Now let's actually use the special constructor. We have written like this constructor that is automatically calling setup, but we haven't used it. Well, by default, if you are creating an object like that, it is always gonna call the default constructor. If it's not available, as you can see, we got the red underlines. However, what you can also do is you can explicitly call the special constructors, and you basically do this by adding brackets and adding the parameters. So if I would go Control-Shift-Tab in here, you can see that Visual Studio gives us this IntelliSense, and this is now showing us all the versions of the constructor that is available. And actually you can see that we have 3 constructors available. You can cycle through them by using the arrow keys. You can see that we have a constructor which is taking a const, function, precacher, function, precacher, ampersand, whatever. This is actually the so-called copy constructor. It is copying an object over. This has something to do with the big 3, but that is something that we're going to talk about maybe in the next video. Probably in the next video, maybe not in the next video, because we still need to talk about references before we talk about the big 3. But that's something that we're just gonna now, we're gonna pretend we haven't seen that. So as you can see now, we have 2 more implementations left. Let's take a look at the third one. The third one is default construct. You can see the function precacher. So if I write this like that, it's not gonna work because the default constructor is not called like that, but it's a different idea. So as you can see, the second implementation is also there. You can see that the second implementation takes our x, count, and function. So I can take in my x here, my count, and my pointer to the function. So if I do this like that, setup is going to be automatically called, and if I hit F5 again, the application is going to still behave the same. It's still going to output the same data here. Maybe now we should actually delete our outputs here because I don't need them. They are now just clogging up our console. But now you can see, like, if I directly put the brackets in here, it's going to automatically create an object and it's going to work. This also works differently. You can also assign PC, so you can say function precacher PC equals to function precacher. This is like doing the same thing, right? As you can see, now this is looking a bit more different. It's looking a bit more explicit. I'm creating a function precacher with these parameters, and I'm going to assign this to PC, but this is still going to do the same thing. What also works here is, of course, with the default constructor. Can say something like PCX equals function precacher. This is then taking the default constructor and assigning it to PCX. So this works as simple as that. And now you can see like that our code is syntactically very nice looking. But I actually prefer that way because it's shorter, like PC, and these are the parameters for PC. And this is a nice way to do it. So PC is created, PC is computed, and PC is printed. Very, very nice and simple to do. Now, one more thing that I want to show to you. So if you're doing this with pointers, it of course also works. I can do a function precacher pointer, FPC, let's just call this now FPC. And if I use the new operator, then I'm going to say new function precacher. This one is automatically calling the default constructor if you don't add something. If you do something like that, it's going to call also the default constructor, but what you can do as well is you can take your x, count the function for x, maybe let's do it twice the count so that you might even see the change here, fpc compute and fpc print, and of course we also want to delete fpc then if we have it as a pointer. And this now is like now explicitly calling the creating a new object, so creating it on the heap, creating a new pointer with the data, and explicitly calling here our parameterized constructor. So if I would run this now, 5 and 5, you can see that we get the output from the first one, and then from the pointer stuff 1 allocated with new and deleted with delete. And it works as well, as simple as that. So not really a big deal. And this is everything that I wanted to tell you today about our function precacher and constructors and destructors. So constructors and destructors, a very important thing on object-oriented stuff in C++ because they are like the magic. They are automatically cleaning up, they are preserving you from memory leak, streaks, they are preserving you from everything, and if you have an early return and the object gets destroyed earlier on before you actually calling your release function, everything is good. Release is called automatically, setup can be called automatically, and there are many things that this thing can do, and it's just really nice to handle this. So that's all about this video, so thank you for watching. Make sure to like and subscribe, and I hope you enjoyed. See you in the next video. Have a nice day. Bye.